Okay, so we are here for our last lesson today. And so we are looking at measures of spread. So if we look at these, it's asking to describe the similarities and differences between the following two graphs. Okay. So the two graphs, I'm gonna be able to do this. Okay. So they both have 16 elements. The mean, median, and mode are all 6. Okay, so we've got what is the average, what is the middle part, and what's the highest part. And so they're both 6, not 66. The data is more spread out on the left, and the data on the right graph is more tightly clustered around the mean. Okay, so in the previous section, we learned how to describe a set of data using measures of central tendency. Just as there are several measures of central tendency, there are also different measures of spread for a set of data. So their interquartile range. So a box plot is a visual representation of data divided into 4 groups. So quartiles with equal numbers of values in each. So the 3 dividing points are Q1, which is your median of the lower half of the data. Q2 is the median of all of the data. So you obviously have to calculate it first. And Q3 is the median of the upper half of the data. So the interquartile range is the range in the middle half of the data. So Q2 minus Q1, or sorry, Q3 minus Q1. The larger the interquartile range, the larger the spread of the central half. So this is a good measure of spread or dispersion, but can be tedious to calculate. So remember, the median is the middle value of an ordered data set. Okay, so we've got example 1 here, the final grades in grade 9 physical education class. So first put the data in numerical order. So we've got 43, 48, 56, 59, 62, 64, 67, 75, 75. Okay, so calculate the following. So our range is 47. Okay, so if we go from 43 to 90, that is our range. The median is your Q2. So you add them all together, divide them by the amount. Or sorry, no, it's your middle number. That was the silliest thing I've ever heard or said, I think. So it's 71.5. So our 2 middle numbers would be 71 and 72, and then you find the mean of that. And so your Q1 is 60.5. So if you look at Q1, that is the median of the lower half. Okay, so you're looking at the numbers between 43 and 67. And so you're looking at having a median between 59 and 62. And so you do 59 plus 62 divided by 2. And the same thing goes for Q3. And so that is the upper half. And so you'll do the same thing. Okay. And your interquartile range is your Q3 minus your Q1, not A1, Q1. Okay, and so we do 79.5, take away 60.5, which is 19. Although a quartile is strictly speaking a single value, people sometimes speak of datum within a quartile. What they really mean is that the datum is in the quarter whose upper boundary is the quartile. So for example, if a value X is within the second quartile, then Q is larger but smaller, equal to Q2. So if your final mark was 75, what quartile were you working within? Okay, so that is between Q2 and Q3. Therefore, it is within the third quartile. Okay. Finally, we've got the standard deviation. So the deviation of a piece of data is the distance it is from the mean of the set of data. If you were to take all of the deviations from entire set of data, square each one of them, and then find the average, you would find what's called the variance. The square root of the variance is called standard deviation. So, in other words, you square each set of data, you find the average, and then you square root that number, and it gives you the standard deviation. Okay, so this is our equation. It can look a little intimidating, but it's really not too bad. Okay, start by calculating the mean of our height. And so if you were to add all of these together, that gives you 1,155. And there are 7 pieces of data, so divide by 5, which gives us 165. Okay, if you do your height, take away your mean, it gives you your deviation. Okay, so you do 183, take away 165 is 18. Okay, I'm not going to keep doing those, but you get the idea. And then -11. Okay. And so you take this number and you square it. So 18 squared is 324. Okay, and your total is 1520. Okay. And so to find your standard deviation, you take that 1520 and you divide it by 7, which means that it is 17.4. So therefore, I don't know why this is so big, but the mean height of the team is 165 centimeters, with a standard deviation of 14.7 centimeters. And that is all.